YouTube channel. Myself, Dhananjay Nayak, studying in College of Engineering. Today, we are going to discuss about subject mathematics. Topic: transformation between the Cartesian and Curvilinear. Introduction. Transformation between Cartesian and Curvilinear coordinate systems are essential in various fields of science and engineering. These transformations allow us to represent points and vectors in different coordinate systems, providing flexibility in problem solving. Orthogonality plays a crucial role in ensuring accurate transformations between coordinate systems. Orthogonal coordinate systems like Cartesian coordinates or rectangular coordinates is represented P into x, y, z, and the representation is done like this. And cylindrical coordinates, they are P into r psi z, x equals r cos psi, y equals r sin psi, z equals z. And spherical coordinates, x equals r sin theta cos phi, y equals r sin theta sin phi, z equals z cos. And this is a representation, and this representation we'll study in brief for the next slide. Cartesian coordinate system. Cartesian system. The Cartesian coordinate system is a branch of mathematics that tells about how to represent a point uniquely in the n-dimensional coordinate plane. The theory of the Cartesian system was proposed by a French philosopher and mathematician called Descartes in the 17th century. This Cartesian coordinate system provided the relationship between Euclidean geometry and algebra, which has revolutionized the study of mathematics. The Cartesian coordinate system is a foundation of analytical geometry and helps in the representation of lines, curves, geometric figures in the n-dimensional plane. And the representation for the Cartesian system is represented as the origin, positive x-axis, positive y-axis, negative x-axis, negative y-axis, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Curvilinear coordinate system. Curvilinear coordinates are a coordinate system or Euclidean space in which the coordinate lines may be curved. These coordinates may be derived from a set of Cartesian coordinates by using a transformation that is locally invertible, one-to-one map of each point. This means that one can convert a point given in a Cartesian coordinate system to its curvilinear coordinates and back. The name curvilinear coordinates, coined by the French mathematician Nayak, derives from the fact that the coordinate surface from the curvilinear systems are curved. Curvilinear coordinates are often used to define the location or distribution of physical quantities, which may be, for example, scalars, vectors, or tensors. Mathematical representation as gradient, divergence, curl, and Laplacian can be transformed from the coordinate systems to another. According to the transformation rules of the scalars, vectors, and tensors, such expressions then become valid for any curvilinear coordinate system. Polar coordinates. Polar coordinate system. The polar coordinate system is a two-dimensional coordinate system in which each point on the plane is determined by a distance from the reference point and the angle from a reference direction. The reference point angulus to the origin of Cartesian coordinate system is called the pole, and the ray from the pole is the reference direction in the polar axis. The distance from the pole is called as radial coordinate. Radial distance, or simply radius on the angle, is called as angular coordinate, polar angle, or azimuth. Angles in polar notation are generally expressed in either degrees or gradients, that's 2 pi grade being equal to 360 degree. Polar coordinates are the most appropriate in any context where the phenomena is being considered in inherently tied in the direction of lines from the center point in a plane, such as spirals. Planar physical systems with bodies moving around a central point of a phenomena originating from a central point are often simpler and more interactive for a model using polar coordinates. The polar coordinate system is extended to three dimensions in two ways: the cylindrical and spherical coordinate system, which will be learning in the next slide. Polar coordinate system. Polar points are written in the form of r, theta. Think of theta as the angle of initial side of the polar axis and the terminal side of 0 degree of the theta degrees are radians. This is the representation of polar coordinate systems. Cylindrical coordinates. The cylindrical coordinate system is a three-dimensional coordinate system that specifies point positions by the distance from a chosen reference axis L in the image opposite in the direction from the axis related to the chosen reference direction axis A, and the distance from the chosen reference plane perpendicular to the axis plane containing the purple section. The related distance is a positive or negative number depending on which the side of reference plane finds as the point. The origin of a system is the point where the three axis coordinates can be given 0. These are the intersection between the reference of planes and axes. The axis is variously called the cylindrical or longitudinal axis to the differentiate of the form of polar axis, which stabilizes in the reference point starting at the original point in the reference direction. Other directions perpendicular along the axis are called as radial lines. Cylindrical coordinates. Spherical coordinate. A spherical coordinate system is a coordinate system for three-dimensional space where the position of a given point is a space specified by three numbers r, theta, psi, and the radial distance of a radial line connecting the point is a fixed point of origin, which is located on a fixed polar axis or zenith direction axis, z-axis. The polar angle theta and the radial r, and the azimuthal angle psi of a radial line r. Once the radius is fixed, the three coordinates r, theta, psi known as theta will provide a coordinate system or sphere, typically called as a spherical polar coordinate, noted being the physical convention followed by the article. See both graphics, physical convention and real mathematical convention. The polar angle theta is measured between the z-axis and the radial r. The azimuthal angle psi is measured by the orthogonal projection, and the radial r is the reference of xy plane which is orthogonal and z-axis passes through the fixed point of origin, and other is fixed with z-axis and x-axis and y-axis, both of which is orthogonal, z-axis fixed with each other. Jacobian matrix. Jacobian matrix represents the differential at f at every point where f is differentiable. In detail, if H is displacement vector, represent a column matrix and the matrix product Jx dot H in another displacement vector. That is the best linear approximation of the change of f in the neighborhood or x. If f of x is differentiable at x, this means that the function of the max y equals f of x plus j of x into y minus x is the best linear approximation of f comma y of all the points at y close to the x. The linear map h cross j comma x is known as derivative or differential of f at x. The Jacobian of the vector valued function in the several variables generalizes the gradient or scalar valued function in several variables, which is then generalizes the derivation of scalar value, that is the single variable. In other words, the Jacobian matrix of a scalar value function in the several variables is transposing the gradient and gradient of a scalar valued function of the single variable as its derivative. Jacobian matrix. In conclusion, transformation between traditional and curvilinear coordinate systems have the vital role in the mathematical modeling of the problem solving. Advanced transformations are orthogonality engineers and specialties to tackle complex problems of coordinate representation. Orthogonality is a key concept in ensuring accurate transformation and maintaining the geometric integrity. Thank you.